Hello everyone. In this video we're going to see one numerical example of the K-means algorithm. We're going to go like step by step from scratch. So let's assume we have 4 data points in 2 variables named f1 and f2. So those are the 4 data points. Every row is one data point, right? And we're going to run K-means clustering with k equals 2, right? So this is the database. Here's a picture of the points, and let's start. So as you know, the initial step is to generate 2 random centroids. So let's assume that the random initial centroids are the ones shown there, 1, 1 and 2, 1. So we plot them here as red crosses. Okay, so now the first thing is to assign the memberships according to those centroids. So to do that, we need to calculate the distance for every data point between the data point and each of the centers. So we can do that with one matrix called the distance matrix, in where points are located as columns and the centroids are located as rows, and we are going to calculate every pairwise distance here. So the first thing will be calculate the distance between x1 and c1. So we can see that since x1 and c1 are the same point, the distance is 0. So this is why we annotate as 0 there. Now we need to calculate the distance between x2 and c1. So x2 is 2, 1 and c1 is 1, 1. So here we calculate the Euclidean distance. It'll be the square root of 2 minus 1 to the power of 2 plus 1 minus 1 to the power of 2, right? So this is 1. Now we calculate the distance between x3 and c1. So it's going to be the distance between 4, 3 and 1, 1. And again, Euclidean distance is going to be 4 minus 1 to the power of 2 and 3 minus 1 to the power of 2. That's the square root of 9 plus 4, and that's approximately 3.61. Doing the same thing between x4 and c1 is going to be the distance between 5, 4 and 1, 1. The calculation is here, and we get 5. So now we need to calculate the distance between all the data points and c2. So between x1 and c2 is going to be 1. Now between x2 and c2 is going to be 0 because they are the same point. The distance between x3 and c2 is approximately 2.83, right? You can see the calculation here. This is 4 minus 2 is to the power of 2 is 4, and here we have 4, so it's the square root of 8. And finally, the distance between x4 and c2 is the distance between 5, 4 and 2, 1, and is 4.24. So this is the final initial distance matrix, meaning the distance between every data point and the current centroids. So now let's call this matrix D0, and now we can calculate the membership matrix. Is basically when we assign the membership of every data point to the different centroids. And let's use a binary matrix for that. For example, x1 is closer to c1 because its distance to c1 is 0, right? So we put a 1 here, telling that x1 belongs to the cluster represented by c1. So this is, we have 1 here. Now for x2, we can see that x2 is closer to c2 because its distance is smaller than the distance between x2 and c1. This is why x2 belongs to the cluster represented by c2, and that's why we use 1 here, right? Now, for x3, same thing. We can see that x3 is closer to c2 because its distance to c2 is smaller than the distance to c1, and then meaning that x3 belongs to the cluster represented by c2, and we put a 1 in the second row. And the same for x4. We can see that x4 is closer to c2, then belongs to the cluster represented by c2. So this is our binary membership matrix called G0. So with that matrix, now we can put the new colors, and we can see that now we have these 3 points belonging to the green cluster represented by C2 and just 1 blue point represented by C1. And we still have the same centroids, right? So now what we have to do is to update the centroids. And for that, we need to calculate the best new centroid on every team. And since we are using Euclidean distance, the optimum centroid is the average. So we calculate the average. So in the cluster 1, it's just one data point, so the average is the same point. But for cluster 2, we need to get the average of the 3 green data points. Basically, we sum the points on every axis and then divide by the number of points. So 2, 4, 5 are the x-axis of the 3 green points divided by 3, and 1, 3, 4 are the F2 axis for the 3 green points divided by 3. And we get this result, 11 divided by 3 and 8 divided by 3. And we can see the new locations here, right? So C1 stays the same, but C2 moves to a more centric position inside the green cluster, right? Okay, given these new centroids, we need to again assign the memberships. So we need to calculate G1. But we know that to have G1, we need to have first D1, which is the distance matrix. So again, we need to go over every data point and calculate the distance between the data point and each of the centers. So now the distance again between X1 and C1 is still 0 because it's the same point. Actually, since C1 is the same as in the previous iteration, all our calculations are going to be repeated and are going to be the same numbers. But now everything changes because C2 changed. So the distance between X1 and C2 is now 3.14. Why? Here's the calculation, right? Now the distance between X2 and C2 is 2.36. Same thing, we calculate the distance between X3 and C2, and finally X4 and C2. So we have the new distance matrix, T1, and now we can calculate the new membership matrix, G1. So we need to go over every column and see what is the closest centroid. For X1, still the closest centroid is C1, because the distance to it is 0. For X2, the closest centroid is C1. For X3, the closest centroid is C2. And for X4, the closest centroid is C2. So now the membership changed. Now X1 and X2 belong to the first cluster, the one represented by C1, as you can see, because they have the ones here in the first row, and X3 and X4 has the ones in the second row belonging to the cluster represented by the centroid number 2. So given these new memberships, we can use now the new colors. We can see that we have now 2 points on each cluster. Still we have the same centroids, so the next step will be to update the centroids. So how? Again, we need to calculate the average. We need to average the 2 points on every group. So in the blue cluster for C1, we need to sum these 2 data points and divide by 2. So we sum the F1 axis and F2 axis and divide by 2. And for C2, the same thing. We need to sum these 2 green points. First in the F1 axis would be 4 plus 5 divided by 2, and then in the F2 axis is going to be 3 plus 4 divided by 2, and we get this result. So given this new result, we can see visually here the centers, and the centroids now are better representatives of each of the groups. Okay, so now we have new centroids, and we need to reassign the memberships. Again, we know that to get the new memberships, we need to get the new distance matrix called D2. So again, we need to go over every data point and calculate the distance between the data point and each of the centroids. So it'll be X1 and C1. Now the distance is not 0 anymore, it's 0.5, as you can see, because C1 changed. The distance between X2 and C1 is also 0.5. And we go over every data point calculating the Euclidean distance, right? So finally, we get our D2 distance matrix. Now with this new distance matrix, we can calculate the membership matrix, and we can see that is this one. We go X1 is closer to C1, X2 is closer to C1, X3 is closer to C2, and X4 is closer to C2. So you can see that G2, which is the new membership matrix, is exactly the same as the previous membership matrix. So in other words, the memberships didn't change, so the centroids will not change. So we achieved convergence, and the algorithm stops. Great, so this is the final result. We can see a picture here of the evolution of the process. We started here with the random centroids, then we assigned the memberships with the colors. We got these memberships, the green one and blue. Given those memberships, we update the centroids, and we got the new position here for the green cluster. The blue stayed the same. Now with these new centroids, we reassign the memberships, and now this point switched to the blue group right here, and we got 2 points in the blue group. And given these new memberships, we could get better centroids here, and we got the final result.